Okay, my next tricky function that I'm going to look at is a piecewise function. These are the functions that use a different formula depending on the value of x. And you might have seen these before with notation like y equals, and then it'll be like a curly brace and some formula, maybe square root of x. And then it would say where that formula applies. The notation that Desmos uses for that is a little bit different. So on Desmos, you have to put the condition first. So let's say that for x less than or equal to 1, the formula we are going to use is the square root of x. And Desmos has drawn that here. Good. And for x greater than 1, I'm going to use a different formula. So I put a comma here to separate the different pieces of the function. That's where the name comes from, piecewise. And the next condition I want is for x greater than 1. I put a colon. The function I want now is e to the power x. So here in blue is the graph of my piecewise function. Down here, I'm using the square root formula. Up top, I'm using the exponential formula, but I've only got one x value, I've only got one y value for every x coordinate, so that is a function. Now, what is the value of this function when x equals 1? Well, algebraically, it's going to be the square root of 1, which is just 1, right? Because 1 is, in fact, less than or equal to itself. So I use the formula, the square root of x. Graphically, it's a little hard to see. Usually I like to draw like a big dot here to indicate this is where the function is defined. I see that I have 1, 1 as my x and y coordinates when I'm hovering on that formula. Let's try this business with the limits, though. And you can already see I've got this jump in the graph of my function. So if I come in from the left, I get closer and closer and closer to the coordinates 1, 1. That's coming in from the left. So it looks like there's a limit there. But if I come in from the right, this time my coordinates are getting closer and closer and closer to something else. It looks like they're getting closer to 1, e, right? E is 2.7 and change. So what's going on is that the left side of the function is trying to go one place. The right side of the function is trying to go a different place. The way we would talk about this is to say that there's a left-hand limit and a right-hand limit, but because there's not a single destination that those functions, these halves of the function are trying to get to, I would say that the limit as x approaches 1 of this piecewise function does not exist. There's not a singular destination that this function is trying to get to. Let's look at a different piecewise function. So I will say from x that is less than 1 gets the formula the square root of x. X that is greater than 1 gets the formula x squared. But we need to say what is the value of x equals 1. And I will give x equals 1 the formula 3. So now I have another piecewise function. Left of the coordinate x equals 1, it looks like the square root. Right of the coordinate x equals 1, it looks like a parabola. a little steep, but you can kind of see the curve there. But at x equals exactly 1, as I trace along my graph, the function jumps up to 1, 3. When x equals 1, I use the formula y equals 3. Does that make sense? When I try to think about this function with my limit idea, coming in from the left, my x coordinates are getting closer and closer to 1. My y coordinates are also getting closer and closer and closer to 1. Coming in from the right, my x coordinates are getting closer and closer and closer to 1. My y coordinates are getting closer and closer and closer to 1. So the limit idea would say that the limit of this function as x approaches 1 is 1. It's the same limit from both sides. It's the same destination. So that limit exists. It's just not equal to the value of the function, which is kind of a strange thing going on, but then again, it's kind of a strange function that I'm asking about. The short of it is that when we are working with piecewise functions defined for different ranges of x, we'll have to be considering what's happening on the left-hand side and the right-hand side of our limiting point. And if the actual formula of the function disagrees with that limit, then so be it. The limit is not equal to the value of the function there. Okay. We'll look at one more function in my next video, and then I'll have some slides.